Now we're going to take a look at some real world situations and see if we can figure out when we're given the equation what some of these things represent. So our first problem here, we have a tree and the height in feet of the tree after X years is 1.5x plus 15. And then it's asking us after how many years is the tree 24 feet tall? So how long did it take that tree to grow 24 feet? So we have a tree and it got planted in the ground. So many years went by and it was 24 feet tall, right? That's what's happening in this story. So we got to think about what some of these things mean. And first we want to think about what does X represent. So if we look back in the problem, the height in feet of a tree after X years. So the problem tells us that X stands for the number of years that passed. Okay. What about the 1.5? What could the 1.5 represent? So the 1.5 is directly attached to the X, which is the number of years. So when you're talking about a tree growing in heights, it would grow so much per year. And again, remember from our do now, that per was attached, tells us that there's multiplication in there. So 1.5 per year. And our height is being discussed in feet in this problem. So it actually grows 1.5 feet per year. So every year that tree grows 1.5 feet tall. And then the last question is asking us, what does the 15 represent? So where did that 15 come from? It was something that happened in the beginning and it doesn't change. So if the story was that this tree was planted, well, the tree had to be a certain height when it was planted or when we first started analyzing this. So that's what the 15 represents. It's something that doesn't change. It was the height at the beginning. It was the starting height. No matter what, no matter how many feet it grows per year or how many years go by, it was 15 feet tall when we first started looking at it or when it was first planted. And then the problem actually wants to know after how many years is the tree 24 feet tall. So that's what happens at the end of it all. So that's where our equal comes in and our 24 feet tall. So our beginning of the equation was 1.5x plus 15. So here's our whole equation now. And we can solve that by doing our inverse operations. Remember, constant is the first step. We're going to move that. And we're left with 1.5x equals 9. Divide both sides by 1.5. They will cancel out on that side. And 9 divided by 1.5 is 6. So it took 6 years for the tree to grow 24 feet tall. So let's take a look at one more. Next problem, we have the cost C in dollars of making N feet of cabinet represented by C equals 18N plus 45. So this time it's written out in a whole equation. It tells us that the cost, right, C dollars is 18 times n, so 18 per n, plus something 45 that never changes. How many feet of cabinet are made when the cost is $441? So it's telling us now that the cost equals, C equals 441. So let's think about what n represents. Well, in the problem, it tells us n feet of cabinet. So that's how long or how many feet of cabinet we have. Actually, it would be more than just length because we have to build the whole thing and it's three-dimensional. So n is the feet of cabinet that was built. 18. What does the 18 represent? So the 18 is attached to those feet, and our problem's talking about dollars. So it's $18 per foot. So for every foot of cabinet that is built, that foot of cabinet costs $18, right? So if you have a drawer that's a foot long, that front of that drawer is going to cost you $18. That's that set cost. What does the 45 represent? So the 45 is going to represent something that does not change. So it could be a couple different things in this situation. It could be a deposit, right? You might have to put a set deposit down when you order a cabinet to be made. That way, if you cancel, the person who's making the cabinet doesn't automatically lose all the money. It could be the cost of a piece of equipment that was purchased to build all of these cabinets over and over again. If you're starting a business, you have to put an initial amount of money out for the equipment. And then every item that you make costs money for those materials to make it. So it's some kind of cost that does not change. You could pick anything as long as it was something that was paid in the beginning, doesn't change. I kind of like the idea of a deposit. So that's what I'm going to go with for this problem. Deposit, and it doesn't change. So then we need to figure out how many feet, right? We don't know n, but we know c at this point. C is 441. So we can substitute that into our equation, 441, because the cost is now that. So it takes that place of that variable. And we just don't know the other variable. So again, we can do our two-step equation and add or subtract the constant first, just like our steps tell us. And we have 396 equals 18n. So we're going to divide by our coefficient. And 396 divided by 18 equals 22. So our cabinet is 22 feet. Okay, you have one problem that you're going to try for your check for understanding.